Welcome back. Yesterday, we left off about halfway through the Find the Epicenter of an Earthquake lab activity. So to finish the assignment today, you're going to need to have your lab paper, your separate piece of paper if you did any extra work like I did, your little ruler, and this is attached in the classroom stream if you need to print your own. We left off with the times in between the S and the P wave. So we looked at the arrival time of the P wave, the arrival time of the S wave, and calculated how much time there was in between. So now we can go back to our directions and we can take the next step. Step 2 says, obtain a card with the time delay scale. That's this little ruler piece right here. Carefully fold the card back on the dotted line. Crease the fold. So right here where it says fold, we are going to fold that back so that the edge of the ruler on that piece of paper is actually the edge of the paper. So just like that. And then when you turn it over, you can see that the actual ruler edge is right along the edge of the paper now. Okay, step 3. Note the delay time for the first seismograph station, New York. So that was 158 seconds. Step 4 says, using a pencil, make a small mark on the time delay scale corresponding to the delay time for New York. See figure 5. So on your little ruler, and I've got mine here, we want to mark 158 seconds. So to do that, we have to figure out what this is counting by first. So if I look at the 0, up here is 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I must be counting by tens. So 158. So here's 100. 1, 2, 3, 4, 5. So there's 150. And then 158 is going to be almost to 160, but not quite. So 1, 2, 3, 4, 5, maybe right about there. And so you make a mark on your ruler with your pencil, and it helps to have a sharp pencil when you do that. Step 5. Obtain a seismic waves graph. So that's the graph a couple pages ahead. Place the time delay scale along the y-axis of the graph, matching the 0 point on the time delay scale with the 0 on the graph. Step 6 says, slowly move the time delay scale along the curved line representing the P wave data, keeping the scale vertical and the 0 point of the scale on the P wave line. Step 7 says, stop when the pencil mark on the time delay scale reaches the curved line representing the S wave data. Make sure the time delay scale is straight vertically. The pencil mark is on the S wave line and the 0 point is on the P wave line. See figure 6. So that is over here. So we're going to be putting our ruler on the graph and looking to see where the 0 to, and ours is going to be 158, matches the distance between those two lines on the graph. Step 8. Follow the vertical edge of the time delay scale down to the x-axis on the graph. This point represents the distance from the epicenter to the seismograph station for that particular time delay. In figure 6, the distance is approximately 780 kilometers. Step 9 says record the distance to the nearest 100 kilometers in the data table on the worksheet. Repeat steps 3 through 9 using the data for each seismograph station. So let's go ahead and go to our graph, which is this page. And the first station we're doing is New York. And we already marked 158 seconds on our card. And I'm going to make that mark a little bit bigger so maybe it's easier to see on the camera. Right there. So then I want to put the 0 of my little ruler on the P wave line, and I want to try to make sure that I keep the ruler straight up and down. And what I'm going to do is slide the ruler along the P wave line, trying to keep it roughly straight anyway. Keep the 0 along the P wave line, and what you're watching for is when the mark on your ruler matches up with the S wave line, and we're not there yet, so there's still a gap. So I'm going to keep going up the P wave line, keep going, keep going. And maybe there, roughly. No, probably not. Gotta go a little further. That looks like about a match right there. Maybe need to back down just a little bit. It's not going to be perfect because we were estimating where that 58 was, and we're also kind of eyeballing this as to whether or not our ruler is straight. So, you know, just to keep things a little bit simpler, I'm going to go with the match right on the line, right here, and then you follow that line down right there. Okay, what is that distance? So this is 1,000, this is 1,500. 1, 2, 3, 4, 5. Must be counting by hundreds. So this distance is going to be 1,400 kilometers. So then we go over here to our data table, and the distance from New York to the epicenter was roughly 1,400 kilometers. And now we need to do the rest of them. So we're going to look at our spacing for Kentucky, or our time for Kentucky. Let's see, Louisville was 51 seconds. So I'm going to get my little ruler. I'm going to try to erase this 158 just so we don't get confused. And now I need to mark 51. So I know this is counting by tens. Here's 0. 10, 20, 30, 40, 50. 51 is going to be barely above that. Just barely above that line. Double check it. 10, 20, 30, 40, 50. Okay. So then I go back to the graph. Do the same thing as before. Put the 0 on the P wave line. Oh, now I got to go down. And let's see, maybe about there. I think that's pretty close. And again, we're right on the line, so that'll keep things easy. So we follow this line right where the ruler is, down here, and that one is Louisville. And that's going to be 400, because again, we're counting by hundreds here. I think I'm going to go ahead and color code these on the graph just so that you know which one is which. Louisville is green. You don't have to color code these on yours. And New York was red. Okay, so Louisville was 400. So I'm going to go to my data table and fill in 400 kilometers. Okay, next one is Green Bay. That is 92 seconds. So I'm going to erase that mark for 51. 92. So that's going to be one mark down from 100 is 90. So 92 will be just above that. So kind of right there. And then we need to go to our graph, put the 0 on the P wave, and slide it up until you get a match. That one's pretty close. Let's go with that one right there. And so we follow the line down. That's going to be 700. That is Wisconsin. And that was 700 kilometers. Okay, Colorado is next. And that was at 141. So here's 100, 10, 20, 30, 40, 10, wait, that's 100, 10, 20, 30, 40. So 141 is going to be right there. Go back to the graph. Slide along the P wave until we get a match. Maybe right about there. Not quite vertical. That looks like a little better match there. So follow that line down, and that is going to be 1200. And that is Pueblo. So over here in the data table, I'm going to fill in 1200 kilometers. And the last one is Phoenix, which was 200 seconds apart. That's going to be a big one. Okay, so all the way up here at 200. So I know it's going to be past everything that we've done so far because it's the longest length of time. So I'm just going to start here and kind of work my way up until I get a match. And I'd say right about there. That's pretty close. Okay, so what line is that? I'm going to follow that line down, and that is 2,000 kilometers. And that was Phoenix, which is purple. Okay, let's go back to our directions. All right. Step 11, obtain a map of the United States. You should have that on the back of your packet here. Note the map scale is 1 centimeter equals 200 kilometers. Convert each distance recorded on the data table in kilometers to centimeters by dividing the distance in kilometers by 200. Record each value as map distance in the data table. So I'm just going to work on my extra work page here, and I need the numbers that we just found. So we found that New York was 1,400 kilometers away. So over here off to the side by New York, we had 1,400 kilometers. And if you've done dimensional analysis in math class, that's what we're doing right now. So 1,400 kilometers is our given, so that goes over 1. Dimensional analysis tells you to cancel the units that you're trying to get rid of, so that means kilometers have to go on the bottom. And put the units that you're trying to find on the top, and that's centimeters. It also told us in the directions to divide by 200, so we know that that is what we're going to do, but this is why. Cancel the kilometers. 1,400 divided by 200 is going to be 7 centimeters. So 7 centimeters on our map is equal to 1,400 kilometers in real life. So map distance, 7 centimeters. Go ahead and do the same thing for the others. Louisville was 400 kilometers. So 400 divided by 200 is going to be 2 centimeters. Okay, 700. Wisconsin was 700. And that's going to be 3.5. Then we're going to do Pueblo, which was 1,200. So that is going to be 6 centimeters. And last we need to do Phoenix, which was 2,000. Oops, that's okay. And that is going to be 10 centimeters. Okay, let's go back to our directions. Now we are on step 12. Choose one seismograph city on the map and obtain a drawing compass. I'm going to do that here on the video. If you don't have one at home, just do your best to kind of sketch in the circles. A ruler would be helpful because then you can measure the appropriate radius and do a better sketch, but it's not necessary. 13 says, using the scale on the map or a metric ruler, set the compass to the proper radius in centimeters. Note, the radius is the distance from the epicenter to the seismograph station.